What problem does the DeepSeek Harness solve, and who is it for?
The DeepSeek Harness, or DSH, is an open-source agent harness that allows developers to compose AI agents using a plugin-based architecture. It's aimed at developers and researchers working on agent systems and AI-powered applications, especially those who want to build modular, extensible, and reusable components.
What does it let someone do that was hard or impossible before?
Before DSH, building complex agent systems required tightly coupled code, making it hard to reuse components and maintain systems over time. DSH changes this by allowing everything to be a plugin, so developers can mix and match different behaviors, tools, and interactions without rewriting large portions of code.
How does the plugin architecture work in DSH?
In DSH, every functionality is a plugin, which can be developed independently and plugged into the system. This modularity allows developers to build and test individual parts of an agent system separately, and then combine them into larger applications. It also makes it easier to maintain and update components without disrupting the whole system.
What are some of the key technical or architectural ideas in DSH?
One key idea is the use of QWERTYs, a framework for spatio-temporal composability. It allows plugins to be composed in a way that respects both spatial and temporal constraints, making it easier to build complex agent systems. Another is the use of TypeScript, which provides strong typing and enhances code reliability and maintainability.
How does DSH support different environments and platforms?
DSH is designed to be cross-platform and works on various environments, including Windows, Linux, and macOS. It supports different runtime configurations and can be extended with plugins tailored to specific environments, making it versatile for deployment across different systems.
Can you explain the concept of spatiotemporal composability in more detail?
Spatiotemporal composability means that agents and plugins can be composed in a way that respects both spatial and temporal relationships. This allows for more flexible and robust agent systems, where components can be arranged and executed in a sequence or parallel manner, depending on the requirements.
What are some practical applications of DSH?
DSH can be used in a variety of applications, such as building AI-powered assistants, automating workflows, creating interactive applications, and developing complex agent systems. It's particularly useful in scenarios where modularity, reusability, and extensibility are critical.
How does the plugin system in DSH make development more efficient?
The plugin system in DSH allows developers to focus on building individual components without worrying about the entire system. This reduces development time and makes it easier to test and debug individual plugins before integrating them into larger applications.
What are the main limitations or caveats of using DSH?
One limitation is that DSH is still in developer preview and may undergo compatibility-breaking changes. Additionally, while it's highly modular, this can sometimes complicate the setup and configuration of large agent systems, especially for users unfamiliar with plugin-based architectures.
How does DSH handle internationalization and localization?
DSH supports internationalization and localization through files like readme, i18, n.yaml, and readmezh.md, which provide localized content. This makes it easier for developers to create applications that support multiple languages and regions.
What are some of the tools and dependencies used in DSH?
DSH uses TypeScript for strong typing and relies on tools like PNPM for package management and Vitist for testing. It also integrates with QWERTYs, which provides the foundation for spatiotemporal composability.
How does DSH support continuous integration and deployment?
DSH includes support for CI/CD through its gitlabsi.iml file, which defines workflows for building and publishing packages. It also supports testing across different platforms and environments, ensuring robustness and reliability.
What is the significance of the pnpmworkspace.yaml file?
The pnpmworkspace.yaml file is crucial for managing multiple packages within the DSH project. It defines the structure of the workspace, allowing developers to manage dependencies, build processes, and other settings for different parts of the application.
Who should actually care about this repository?
Developers and researchers working on AI agents, especially those interested in modular, extensible, and reusable components, should care about this repository.